Welcome to my channel, CISC Topper Classes. Today we are going to solve M.L Aggarwal Class-9 Exercise 1.2 question number 1 to 8. If you like this video, please like, share and subscribe my channel. Here we are going to discuss question number 1 to 8. Hello everyone, today we are going to solve exercise 1.2 exercise of M.L Aggarwal Class 9 ICSE books. So the main thing which I am going to use in this exercise are these two theorems. First theorem is, if a is any natural number and p is a prime number such that p divides a square, then p divides a. If this number is a prime number and it divides a square, then the theorem says that p will also divide a, the single number which is a. Now the theorem 2 is, if a and b are any natural numbers and p is a prime number such that p divides ab, then p divides a or p divides b or p divides both. Means अगर ये दोनों नंबर नेचुरल नंबर है और p कोई एक प्राइम नंबर है और p a इंटू b के प्रोडक्ट को डिवाइड करता है, सो p विल डिवाइड a, ईदर p विल डिवाइड b और p will divide both a and b singularly. So this is the theorem which I am going to use frequently in this exercise. So learn it by heart and revise it many times. Today we are going to solve exercise 1.2 question number 1 to 8 of M.L Aggarwal class 9th book. Today we are going to solve exercise 1.2 rational and irrational number M.L Aggarwal class 9th ICSE. So the first question is, prove that under root 5 is an irrational number. So we will firstly let under root 5 as an rational number and then we will solve the question. So let under root 5 as a rational number. We have put under root 5 equal to p by q. On squaring both sides we will get 5 is equal to p square by q square. Then it forms first equation as p divides here p as 5 divides p square. So 5 will also divide p according to the first theorem which we have previously read about. If p is equal to 5k, where k is somewhat any integer, because 5 divides p, so it will form an equation. Putting first equation in equation 2 which is given here, we will get 5q square is equal to 25k square, because we have to square the p in the second equation. Then 5 and 25 we will cut it. Q square is equal to 5k square will come, as 5 divides q square and 5 is a prime number, so 5 will also divide q. Hence, as p and q have 5 as a common factor, and this contradicts that fact that it is a rational number. Hence, under root 5 is a rational. Under root 7 is equal
now
to p
let
by
us solve
q,
question
and
number
let
2.
7
Question
be a
number
rational
2
number.
says,
Put it in
prove
the form
that
of
under
p by
root
q,
7 is an irrational number.
equal to.
So let us
So on
solve it.
squaring both sides we will get 7 equals to p square by q square. 7 equals to p square by q square. Now forming an equation, it will form an equation 7q square equal to p square. Let it a first equation. As 7 divides p square, so 7 is a prime number, so 7 will also divide p according to the theorem first. Hence p is equal to 7k, where 7 is 7k, where k is somewhat an integer.
Now putting second equation in the first equation, we will get 7q square is equal to p square. Putting p as a value, 7k ka whole square. We will get 7q square equals to 49k square. We will cut it. We will get q square is equal to 7k square. As 7 divides q square and 7 is a prime number, so 7 will also divide q. Now, as it contradicts that fact that it is a rational number, because rational number has only one common factor 1, and it has p and q has 7 is a common factor, so it is an irrational number. Under root 7 is an irrational number, hence proved.
Question number 3 says, prove that under root 6 is an irrational number. So let us solve this question.
Let under root 6 be a rational number. So put it in the form of under root 6 is equal to p by q. On squaring both sides, we will get 6 is equal to p square by q square, and multiplying we will get 6q square is equal to p square. It will form first equation. Then as 6 divides p square and as 2 divides p square, and 2 is the prime number, 2 divides 6q square, hence 2 divides p square. So 2 divides p also, because it is a prime number, 2 is a prime number. So it will form the equation p is equal to 2k, where k is an integer. It will form the second equation, p is equal to 2k. Putting the second equation in the first equation, we will get 6q square is equal to 2k ka whole square. Now on solving it, we will get 3q square is equal to 2k square, as 2 divides 3 or 2 divides q square. So as 2 divides 3 is impossible, hence 2 will divide q square, and 2 is a prime number, so 2 divides q also. As this contradicts that fact that it has a common factor 1 in rational numbers, hence proved that under root 6 is an irrational number.
Fourth question is, prove that 1 by under root 11 is an irrational number. So let us solve this question.
Let 1 by under root 11 is equal to a rational number. Put it in the form p by q. 1 by under root 11 is equal to p by q. On squaring both sides, we will get 1 by 11 equal to p square by q square. On cross multiplication, we will form an equation first, which is 11p square is equal to q square. As 11 divides q square and 11 is a prime number, so 11 will also divide q according to the theorem first. Now forming the second equation, as 11 divides q, so q is equal to 11k, where k is somewhat an integer. So writing q is equal to 11k. This forms the second equation. Putting the second equation in first equation, we will get 11p square is equal to 11k ka whole square. Now as P and Q have common factor 11, hence it discards that, it contradicts that fact that it is a rational number. So proved that 1 by under root 11 is not a rational number, it is an irrational number. Writing it as P square is equal to 11k square. So let us write the fact.
Fifth question is, prove that under root 2 is an irrational number, hence show that 3 minus under root 2 is an irrational number.
Let under root 2 is a rational number. So putting it in the form of same method only, under root 2 equal to P by Q, and then squaring, then doing all those things. Let us do it. Forming the first equation according to the previous question which I have done. We will get 2q square is equal to p square, as 2 divides q square and 2 is a prime number, so 2 divides q. Then q is equal to 2k, where k is an integer. You can see that the same method we are using in these questions. So these are very simple questions. We have to only focus, and one method and 2 theorems we have to learn it. Putting the second equation in first equation, we will get 2q square is equal to 4k square, and then cancelling both sides we will get q square is equal to 2k square. As 2 divides q square and 2 is a prime number, so 2 will also divide q. In the previous we have seen that 2 divides p square, so 2 divides p. Now we will get that under root 2 is an irrational number, as it has a common factor 2, which contradicts that fact that it is a rational number. Now the second part of this question is we have to prove that 3 minus under root 2 is an irrational number. So let it a rational number and then prove the same method we have to apply. We have to send to that side 3 minus r is equal to under root 2. As 3 minus r we have let it as a rational number, so 3 minus r, 3 is also a rational number, so we will get on subtraction a rational number, and it contradicts that fact that 2 is an irrational number, because here it is proving that it is a rational number. So hence prove that. So let first, there are two parts of this question where we have to prove that under root 3 is an irrational number, and hence because of that we have to prove that it is an irrational number, 2 by 5 under root 3. So following the same method of the previous question, under root 3 is equal to p by q, and on squaring both sides
prove that under root 3 is an irrational number, hence show that 2 by 5 under root 3 is an irrational number.
So 3 will also divide.
So let us solve this question.
Forming the second equation like that, we will get p is equal to 3k, where k is any integer. These are very simple questions. You can see only the same method is going on in the exercise. P is equal to 3k, where k is an integer. Putting the two equation in the first equation, we will get 3q square equal to 9k square. Cancelling both sides, we will get q square is equal to 3k square. As 3 divides q square, so 3 will also divide q, and as it contradicts that fact that it is a rational number, so under root 3 is an irrational number, hence proved. Now 2 by 5 under root 3, let it also a rational number. So putting 2 by 5 under root 3 equal to r, and sending 3 on the right hand side or left hand side, we have to put under root 3 in the one side. Two by 5 under root 3 equal to r. Now under root 3 is equal to 2 by 5r. 5r by 2. Under root 3 is equal to 5r by 2, as 5r by 2 is a rational number and 3 is a rational number according to this, but it contradicts that fact that 3 is an irrational number, which we have previously proved. So hence proved that 2 by 5 under root 3 is an irrational number, only that it can satisfy the fact that under root 3 is an irrational number, hence proved from the first part of the question. Now under root 5 is a rational number. Following the same
Seventh
method
question is,
previously we have
prove
used
that under root 5 is an irrational number, hence show that minus 3 plus 2 under root 5 is an irrational number.
The first equation. After that, so as 5 divides p square, so 5 will divide p. Hence p is equal to 5k, where k is any integer. Now putting this second equation in the first equation, we will get that 5 divides q square, hence 5 divides q. So let's do that. Putting 2 in 1, we will get as 5 divides q square, and 5 is a prime number, hence 5 divides q. And this contradicts that fact that under root 5 is a rational number, hence proved that under root 5 is an irrational number. And following the first part, we will get the answer of second part also, we will prove it. Hence under root 5 is an irrational number. Now let minus 3 plus 2 under root 5 as a rational number and put it as minus 3 plus 2 under root 5 equal to r. Sending under root 5 in the LHS or left hand side or right hand side, we will get minus 3 r plus 3 by 2 under root 5, and r plus 3 by 2 is a rational number, so under root 5 is a rational number, hence it contradicts the previous part which we have solved, that under root 5 is an irrational number. Hence proved that r minus 3 plus 2 under root 5 is an irrational number, only then we can prove that under root 5 is an irrational number. Hence proved the question.
Question number 8 is prove that the following numbers are irrational. First question is 5 plus under root 2. We have to prove this that it is an irrational number. So let us solve this question.
As 5 plus under root 2, let it equal to r be a rational number. If we send 2 on the left hand side or right hand side, we will get 5 minus r is equal to under root 2. As 5 minus r, 5 and r both are rational numbers, so we will get a rational number. So under root 2 is also a rational number, but this contradicts that fact that under root 2 is an irrational number. Hence proved that 5 plus under root 2 is an irrational number. So it is very simple question. You all can do that. Three minus 5 under root 3 equal to r. Let it a rational number and send under root 3.
Now the second part of question number 8 is 3 minus 5 under root 3. We have to prove that it is an irrational number. So let us solve
3
this.
minus r divided by 5 equal to under root 3. As 3 minus r by 5 is a rational number, so under root 3 is also a rational number, but it contradicts that fact that under root 3 is an irrational number. Hence proved that 3 minus 5 under root 3 is an irrational number, because then only it can satisfy that under root 3 is an irrational number. Hence proved.
Question number 8, third part is 2 under root 3 minus 7. So let 2 under root 3 minus 7 be a rational number.
Applying the same as the previous one question. We will get that 2 under root 3 minus 7 is an irrational number. To prove that under root 3 is an irrational number.
Question number 8, last part is 4th under root 2 plus under root 5. This is the last question of this exercise 1.2. So let us solve this question.
Here we have proved that on squaring we will do under root 2 plus under root 5 equal to r. On squaring both sides we will get 5 is equal to r square plus 2 minus 2 under root 2r. We have exchanged the side here. On solving we will get r square minus 2 under root 2r equal to 3. Now sending under root 2 on the LHS or RHS side, we will get r square minus 3 by 2r. As this is an irrational number, it contradicts that fact that under root 2 is an irrational number. Hence proved that under root 2 plus under root 5 is an irrational number. Thank you for watching my video. If you like this video, please like, share and subscribe my channel.